Hello and welcome back to Math 8. This is a video over Unit 2, Section 4, and we're going to be talking about proportional relationships. So our objectives today, we want to determine whether a linear function is a direct variation. We want to solve problems involving direct variation, and then compare proportional and non-proportional linear functions in the form of table, graph, or equation. So let's talk about what direct variation is. Direct variation is a type of equation, okay, where you have y equals kx, where k is the constant of variation. K is the slope, okay, in a nutshell. And what I notice is that, we have y equals kx. We don't have any other constant number out here, okay? So we have something, various, situations can give us this, but that the idea is that k is the slope, okay? Now, what this says here is that a proportion sets two ratios equal to each other. So what I want to do is just calculate the slope. And let's do, the slope between these 2 points, as we increase x by 1, okay, the y values over here increase by 3. All right, and we've been looking at tables like this for a while, okay? But what I want to do is look at a situation where if I use my slope formula here, I get this. I get, let's say we take the first 2 points here, okay, and we create points out of those. Okay, so I'm going to take these 2 points here, 1, 3, and 2, 6. Okay, and I'm going to calculate the slope between these 2 points. All right, and see what we get. We should get 3 over 1 because we know that as x increases by 1, y increases by 3. So this is x1, y1, x2, y2. So our slope m is equal to 6 minus 3 over 2 minus 1. Now, what we're going to end up getting here is that we get 3 over 1, so our slope, m, is equal to 3, okay? But I want to do a couple of other points. I want to do, say, this point, 1, comma 3, and then 4, comma 12, okay? So let's do the same thing for those points, 1, comma 3, and 4, comma 12, all right? And let's just see what happens. Now on this, we're going to get 12 minus 3 over 4 minus 1. 12 minus 3 gives us 9. 4 minus 1 gives us 3. Okay, now the interesting thing is that we can divide these numbers out, okay? 9 divided by 3 is going to give us 3, okay? So we get a slope of 3. Now what I want you to see here, a proportion is when two fractions equal each other, okay? And so the proportion that I want to talk about that we can get from a direct variation is this. And that's that we get 3 over 1 is equal to 9 over 3. Now, one way, that's two equivalent statements. Now, we can divide 1 by 3 and 3 into 9, and we get just a number of 3. So that's one way to verify it. Another way to verify it is to be able to cross multiply. Doing 1 times 9 is equal to 3 times 3. Okay, 1 times 9 is 9. 3 times 3 is 9. 9 equals 9. Okay, and so we know that those two fractions are going to be equal. Okay. Now, another way to look at this, if we look at the definition of direct variation, is the relation in which the quotient of the dependent and independent variables remains constant. Okay, so what we can do is we can actually take the numbers from our y value divided by our x value. We should all get the same thing. So check this out. So if I take 3 divided by 1, okay, if I take 6 divided by 2, okay, and all I'm doing is just taking my y value and dividing it by my x value. Okay, if I take 9 divided by 3 and 12 divided by 4, all of these represent the same thing of 3. Okay, so if you can take your y value and divide it by your x value and you keep getting the same thing, okay, then you have direct variation. Okay, so let's take a look here. On this one, it says a recipe for banana bread calls for 1.5 cups of flour for every banana used, okay? Now, there's a couple of different things we can notice here. The first thing I notice is that as x increases by 1, okay, the y values increase by 1.5, okay? And that's just something that, I'm just looking at this and drawing that conclusion, okay? I'm looking at this pattern, I'm going, okay, well, what's going on here? Now, here's the other thing. The constant of variation can be calculated, okay, if we have direct variation. So if I take 1.5 divided by 1, or if I take 3 divided by 2, if I take 4.5 divided by 3, if I take 6 and divide it by 4, if I take 7.5 and divide it by 5, we're going to get 1.5. So if I find what k is, okay, if I know it varies directly, then I can do this. I can say, all right, well, I have the equation y equals kx, okay. We could do a number of things here, okay. You can just calculate your slope, all right, using those 2 points, or using this concept of direct variation and saying, all right, well, when y is 2, we know we have k and then x is 3, okay. And we can solve for k by, wait a minute. No, when y is 3, sorry. Y is 3, x is 2. So 3 equals k times 2. So divided by 2 on both sides. Sorry about that. And k is going to equal 1.5. Okay, and you could do that with other points. Okay, you could also do that with, I'll use 6 and 4. So 6 is equal to k times 4. Divide by 4, divide by 4. K is equal to 1.5. Okay, so when I do that, we can figure out an equation and say that y is equal to 1.5x, okay? And that's what we've got, okay? All right, let's take a look at this last problem here. It says an animal shelter requires twice as many kennels for cats as for dogs. Which value is represented by x, which by y? Okay, so what we know is that the number of dog kennels is our x value, okay? And our number of cat kennels depends on the number of dog kennels. Okay, so what I have is that we have cats have twice as many, okay? And let's just go ahead and plot these points here real quick. Okay, so I've got the point 1, 2. I've got the point 2, 4. Whoops. 1, 2, 2, 4. 3, 6, 4, 8, 5, 10. Now, all these points create a line that goes back to the origin, okay? Now, here's what I know, okay? I can write an equation based off of this, okay? I can say that y equals kx. If I know that it varies directly, okay, what I can do is I can say that when y is 2, okay, x is 1. All right, I can say that when y is 4, x is 2. All right, and what we can do is we can solve for y in all these instances, and we keep getting, or solve for k, I mean, and we get that k is 2 here, and we get that k is 2 here. Okay, so we keep getting that k is equal to 2. So what we know, all right, that we can write an equation that is like this and say y equals 2x, okay? So it's pretty much just like writing linear equations, but it's using a concept of knowing this concept of varying directly, okay? And if we know that, then it's easy for us to write the equations. Now in Section 5 and Section 6, it's going to get a little bit trickier because we'll have a y-intercept. So let's stay tuned for that. Let's get started on our work, and we'll see you in a bit. Thanks a lot. Bye.